Alright, so this is where we were last time. We'll continue. Now, we already took care of these statements. Let us partially erase the board. Okay, good. Now, as I promised, we're going to put some numbers to these things and do some examples. Suppose you have u is the vector 5, 2, and v is the vector 7, 4. Then, what is the dot product of u and v? U dot v is equal to. Now, here, remember, if you should draw u, before we do the example, if you should draw the vector u, this would be 0. This u, it would be over, and by the way, if we were typing it, we would type these bold, but if you indicate that there are vectors in your book, you write a little line under it. Alright? I won't always do this here because it's kind of distracting to have to be drawing the line under the vector, but in exam and in your book you should draw the lines under it. Here, this is over 5 and beside 2 if you use this as your x and y axis. Oh my, I draw the x-axis out of place. The x-axis would be somewhere here and the y-axis here, right? That's what it means, right? So the vertical and the horizontal v would be something like this. This would be over 7 and this beside 4, right? So horizontal and horizontal, vertical and vertical. See that? So the dot product means to multiply. So it will be 5 times 7 plus 2 times 4. It will be 5, 7, 35 plus 2 4s 8. 35 plus 8 will be what? 35 and 8, that's 35 and 5 is 40 and 3 more 43. Now notice the dot product is a scalar quantity. It doesn't have any direction. Alright? Now, let's look at another example. Suppose the vector u is negative 3, 6. And the vector v is 5, negative 2. What would be u dot v? Also v dot u. Let's see both of them. U dot v would be negative 3 times 5 plus 6 times negative 2. Horizontal times horizontal plus vertical times vertical. You see that? So, what you have? 3 by 5. Negative 15 plus 6, 2 is negative 12. Negative 15 minus 12 would be negative 15 minus 10. Negative 27. What about u dot v now? U dot v. Remember? Horizontal. Oh, v dot u, I mean. We just did u dot v. It's v dot u now. It's going to be horizontal by horizontal. 5 times negative 3 plus vertical by vertical. Negative 2 times 6 would be negative 15 plus negative 12. Negative 15 minus 12 would be negative 27. Same negative 27, right? So, that's the dot product of the vectors. Alright? Now, let's do another example. Suppose, oh, let me erase this too. Suppose you have a vector u is equal to 1, 1. And the vector v is the vector 2, 2. Oh, let's not bother with that. Let's not use 1. 1 times anything gives you 1. So it won't be as exciting if you use 1. 2, 2, and 3, 3. What is u dot v? It will be 2 times 3 plus 2 times 3, which is 6 plus 6 equals 12. Alright? So the vector 2, 2, the vector 3, 3 would lie on top of that vector 2 and come out here. So you have 2, 2 on the x and y axis. And you have this one at 3 and this one at 3. Alright? So, what you have then, as the dot product is 12. See that? Now, that will be that for now. We're going to see a few more things after we go to the next video.